what was the universe like at the cosmic dawn? The cosmic dawn is the time just a few 100 million years after the Big Bang, which marked the ignition of the very first stars, illuminating the cosmos. To observe this period, a theoretical time machine is necessary, and remarkably, we have not just one, but many. Although light travels at an astounding speed of 1 billion kilometers per hour, the vast distance of galaxies means it takes millions or even billions of years for their light to reach us. The farther these galaxies are from Earth, the more extended the duration for their light to reach our observation point. Collecting a sufficient amount of that light for scientific purposes, let alone creating aesthetically pleasing images, necessitates a substantial telescope with a heightened sensitivity to infrared emissions. This is precisely why the James Webb Space Telescope was constructed. Boasting a substantial 6.5-meter segmented mirror and multiple instruments attuned to infrared wavelengths, it has the capability to observe galaxies as they existed shortly after the first star's formation, and potentially even reaching back to the cosmic dawn. To push the boundaries of Webb's capabilities, astronomers devised a specialized observation initiative known as the James Webb Advanced Deep Extragalactic Survey, or JADES. This program focuses on a minute section of the sky, conducting extended observations to capture deep field images of immensely distant objects scattered throughout the universe from Earth. Now, the telescope is pushing the observations even deeper into the universe, taking the measure of galaxies closer to the cosmic dawn, uncovering secrets about the universe's history. And this seems to be the latest breaking news from the James Webb Telescope. It has helped astronomers determine the distance to nearly 200 galaxies and galaxy clusters formed during the cosmic dawn. Using JADES, Canadian astronomers are the first to measure galactic distances in this image, showing huge collections of stars at the edge of the observable universe. Now, astronomers still have questions about what happened immediately after the Big Bang, such as how light emerged, how the first stars formed, and when the first galaxies came together. This new study revealed newer galaxies in the SMAC 723 galaxy cluster, but there are other findings that came to light that have the astronomers shocked. The team spotted 3 objects with greater than normal densities than one would expect in a lone galaxy. This suggests that it is not alone at all. SMAC 723 may host 3 newly found galaxy clusters roughly 8 to 10 billion light-years away from Earth. What's more, one of these over-dense regions hosts Sparkler Galaxy, revealed in September 2022. Sparkler is 9 billion light-years away and could host the universe's first star clusters. The newly found overdensities suggest the Sparkler is not an isolated example. Meanwhile, the telescope has begun hunting for signs of the first stars to switch on in the universe, the so-called population 3 stars, gigantic balls of fire purely made of hydrogen and helium that shined brilliant and brightly to bring the first light to the universe. But finding them has been very difficult, as they kind of hide in the background. So far, we haven't had any possible detection of such stars, but they must exist as per our models. This is where humanity's most advanced pair of eyes enters the scene, and its finding indicates 2 new results, bringing us closer to the first stars of the universe than ever before. Using the telescope, 2 teams of astronomers have reported promising signs of population 3 stars. In the first study, researchers from the University of Cambridge may have stumbled upon a pocket of population 3 stars nestling in the outskirts of a remote galaxy. In the second study, from the National Institute for Astrophysics in Italy, hints at a tiny galaxy that may be composed of extremely primordial stars born early in the cosmos. 400,000 years after the Big Bang, when the universe had spread out and finally cooled sufficiently, the first atoms formed as electrons began to get trapped in orbits around nuclei. These were mainly helium and hydrogen, which are still by far the most abundant elements in the universe. These atoms would have clumped together into immense clouds under gravity and eventually formed population 3 stars. Unhindered by competition from other stars, these stars may have grown to huge sizes within these clumps, at least hundreds or even thousands of times more massive than our Sun. This bulk meant the stars were short-lived, exhausting their fuel and exploding as supernovae within just a few million years. Yet those explosions were vital to the universe. They released heavier elements that had formed inside the stars, such as oxygen and carbon, which gave rise to population 2 stars and later population 1 stars such as our Sun, and even planets such as Earth and life itself. But it's those short lifetimes of population 3 stars that have made them tracking difficult, but not impossible. The immense heat of the stars, about 90,000 degrees Fahrenheit on their surface, which is 10 times the temperature of our Sun, should give off a telltale hint of helium that could only have been produced at such temperatures, because they are very small from our viewpoint and likely muddled with later population 2 stars. However, they have been undetectable by most telescopes until the James Webb. Searching for population 3 stars in the early universe is a key part of the science that James Webb was built to accomplish. They are a missing piece in our understanding the history of the universe. The team at the University of Cambridge used James Webb to observe a galaxy called GNZ 11 that was previously discovered by the Hubble Space Telescope in 2015. GNZ 11 dates back to just 400 million years after the Big Bang and was the most distant known galaxy until Webb discovered ones that are farther away, like Massey's galaxy. Taking apart the light at the galaxy's edge in a process called spectroscopy, they found hints of helium that could be linked to small pockets of population 3 stars in the galaxy's outer regions. If correct, the stars in the clump would have masses at least 500 times that our Sun, with a total mass of 600,000 solar masses, which would explain the signals seen by the team. Meanwhile, the team in Italy took a different approach. Using the gravitational bulk of a galaxy cluster called MAX J416, the team detected what appears to be a magnified emission of hydrogen and a small amount of oxygen from a very small and very remote galaxy. While the researchers were not able to see the light of the galaxy directly, their findings suggest the presence of 2 extremely small clumps of stars in the early universe, perhaps totaling less than 10,000 solar masses altogether and seen about 800 million years after the Big Bang. The clumps do not seem to be solely composed of population 3 stars, but the amount of heavy elements present is incredibly small. The heavy element abundance is lower than anything else we have seen in the universe, the lead researcher said. It's as close to a primordial galaxy as we've seen. Well, I think that seeing such clumps of population 3 stars may be the limit of what is possible with the James Webb Space Telescope, allowing us to confirm the existence of these stars at particular epochs of the universe and telling us something about the sizes they grew to. There is a slim possibility, however, that the telescope may be able to resolve individual population 3 stars if they are magnified sufficiently, perhaps around a galaxy cluster in future observations. For now, our best bet is looking for the emission from small clumps of stars, a task that James Webb Telescope is perfectly suited to. If we can find them, it opens a whole new understanding of how our universe began. We know that without the chemical enrichment of first-generation stars, there wouldn't have been anything else. But we want to know how it all started, and information from population 3 stars would open up a door that we never stood in front of. What do you guys have to say? Isn't it exciting times for science and astronomy? The first generations of stars are responsible for us being where we are today, for us existing. Take a moment to let that sink in. And if the research confirms that their findings, in fact, proof the signals are from population 3 stars, Then we will be looking at what made us. And the way the James Webb Space Telescope is going, I think it isn't too late before we have uncovered mysteries of the universe that will change our understanding of it forever. What do you think? Drop in your comments below, and don't forget to subscribe to Cosmos Prodigy.